When graphing an exponential function, two of the most important things you need to know are its horizontal asymptote and whether it's an exponential growth or decay equation. You can use the various transformations to graph these functions, but I'm going to use a TI-8384 table function to do this because it works pretty well. If the calculator you have doesn't have a table feature, not that big of a deal. You can just plug in the values directly into the function and get your points that way. So here we're going to graph this exponential function, f of x equals -3 times 1/2 raised to the x minus 2. So first thing is I want to find its horizontal asymptote. And by the transformation of functions, it's not going to move. There is no plus or minus at the end back here of the function. So I know that my horizontal asymptote is going to be y equals 0. And I'm going to look to see if this is a growth or decay equation. It's a decay equation because of the 1/2, but the negative here is going to cause it to flip. And so I'm not going to worry too much about the growth or decay part. Not yet. I'm going to let the points kind of guide me towards the solution. So I know that y equals 0, and I'm going to graph that horizontal asymptote now. So I just put my dotted line in, just so I can emphasize this where it is. And now I'm going to graph this equation, but I'm going to use my calculator to help me. So, calculator, and I'm going to plug it into y equals, so -3 times 1/2 raised to, and it's a good idea to get used to using parentheses, just in case something bad happens. Parentheses are pretty easy to use. Calculator understands it. So that's what I'm going to do. So -3 times 1/2 raised to the x minus 2. I'm going to verify that my table is going to start at 0 and go up in increments of 1. So everything's on auto. I'm happy. So now second graph to get my points. And got some interesting ones here. So my graph only goes up to 10, so I'm going to try and limit myself. So I'm going to use 1, -6 for my first order pair. So 1, -6, and then 2, 3, -3, excuse me. And then my last order pair, I'm going to use 3 and -1.5. So 3, -1.5. So you can go further if you want to, but I'm going to use these for now. I might change my mind in a minute. We'll see. So at 1, -6, so 2, 3, 4, 5, 6. And then at 2, -3, so 1, 2, 3, and then 3, -1.5. So 1.5 here. So it has this kind of a shape going on to it. So I'm going to just draw the line or the curve like this, looking like that. And so I'm going to hit graph and see what it looks like, just to verify. Ooh. Looks pretty good. They both look the same in the same quadrant, doing that. So I'm happy with this. So here's a graph of this first function here. And now let's go on and do the next one. This one actually has e in it, but we're not going to treat it any differently. So first things first, get my horizontal asymptote. So I see that this is a +2 here at the end. So I know that my horizontal asymptote has moved up 2 spots. So it's going to be y equals 2. So right here. And now I'm going to get some points. So go into my calculator, y equals, and I'm going to put in my function. So it's going to be e raised to x plus 3. So to do e raised to, you're going to press second and ln down here. It'll do the raised to for you with the parentheses. So x plus 3. And then I'm going to do plus 2. So here's my function. all typed in, still at 0 and going up at 1. Everything's on auto. So let's get the table. And I'm going to see that this is growing pretty darn big, way outside my graph. So let's go up. And I got nothing but decimals. But it's okay, because we can graph decimals as best we can. So I'm going to do the nice one, negative 3, 3. So negative 3, 3. And then the next one is going to be negative 2. And it's going to be a decimal. I'll say it's 4.7. I'm rounding to 1 just because I'm not going to be able to graph any more accurately than 1 decimal. And even at that, it's going to be kind of hit or miss. And then I'll do negative 1 and 9.4. Again, hit or miss. And oh, I did forget to do that, but it's okay because we haven't graphed it. Looking at this, this is E. There's no negatives here, so it's not going to be flipped around. So I know this is a growth equation. So I know its basic shape should look like this. So let's see if our points match that. So 1, 2, 3, negative 3, 3, so here. And then negative 2, 4.7, so negative 2, 4.7, we'll say right there. And then negative 1 and 9.4, so negative 1, 9.4. So the graph should start here and then kind of go up, kind of fastish. Well, let's see if it is. Let's see how accurate we are. Hit graph, and it's pretty darn accurate. Looking pretty good. So when you're dealing with E, you're most likely going to be having a lot of decimals. That's just the nature of the game. So don't worry too much about it. Just kind of graph it as best you can. You're not a computer. That's why I'm only going to 1 decimal deep, just so I can be as accurate as I can humanly be. But you're not a computer, so don't try and graph like you are one.